Hi guys, today we're going to go ahead and review drawing Lewis dot diagrams or Lewis structures for compounds that have covalent bonds that share electrons between elements. So first rule that we need to remember is the octet rule. So we're going to start with simple Lewis structures. This rule you guys learned about already in your previous chemistry class. So just a reminder that all elements when they form covalent bonds want to get 8 electrons in their valence shell in order to be full and stable. Except for hydrogen. Hydrogen's an exception to that. We'll only need 2 electrons in order to be considered stable because it only has one sublevel to hold electrons. This is going to be true for all of our second row nonmetals. Once we get beyond the second row, then there's kind of a new set of rules that apply, and we're going to talk about those today, some exceptions to the rules, which are things that you have not learned yet. So actually, instead of calling these rules, let's go ahead and call these steps. These are steps that we're going to follow in order to draw Lewis structures. So we want to follow these steps in order so that we get our Lewis structures drawn correctly. If you guys don't have a periodic table, go ahead and get one out so that you can use your periodic table to figure out valence electrons for different elements. I'm going to go through 3 examples with you guys. SO2, NO3 minus, that's nitrate, and then carbon dioxide. And I'm going to go through the drawing of these, following these different steps and just reviewing those with you. Okay, so step number 1, let's start with SO2. Step number 1 is going to be to count the total number of valence electrons available. This is going to be important so we know how many electrons to put in our diagram. We're talking about valence electrons, not total electrons. Those core electrons don't matter. It's only the ones on the outside that are available to form covalent bonds anyways. So remember, group number is going to tell us what number of valence electrons it has. If it's in group number 1A, it's got 1 valence electron, 2A has 2 valence electrons, and so on. So sulfur is in group 6A, so it has 6 valence electrons. Oxygen is also in group 6A and has 6 valence electrons, but there are 2 oxygen atoms, so we have to multiply that number by 2. Total, that gives me 18 electrons. That's valence electrons. That means that the diagram I draw has to have 18 electrons in it, no more and no less, okay? So step number 1 is to count your total number of valence electrons. Step number 2 is to connect everything with a single bond. Okay, so the first thing is to look at your compound and figure out what element needs to be in the middle. It's usually the one that is listed first, but it is also the one that has the lowest electronegativity value. So in this case, we have sulfur in the middle, and then my 2 oxygen atoms are going to spread out evenly around that central atom. So I've connected everything with a single bond. We're going to start with single bonds, and then we'll continue from there. Okay, step number 3, give pairs of electrons to external atoms. And let's go ahead and add to this to complete octets. So my external atoms are my oxygen atoms here. I want to add electrons around the outside of each one of these oxygens in order to get 8 total electrons. Let's also remember that every line that I draw represents 2 electrons. So this line here represents 2 electrons that are being shared between sulfur and oxygen. This line here represents another 2 electrons that are being shared between sulfur and this oxygen. So I'm going to go ahead and draw pairs of electrons around the outside of my external atoms so that I complete the octets. All right, that was step number 3. Now what I'm going to do is step number 4, which is really important. Recount the number of electrons on my diagram. So I have 2, 4, 6, 8, 10, 12, 14, 16 electrons. But remember, my diagram needs to have 18 electrons, so this diagram is not complete yet. So after I've recounted and I have 16 electrons, if I need more electrons on my diagram, I'm going to put them on my central atom. So I had 16, I need 18. I'm going to go ahead and put 2 more right there for sulfur. That gives me 18 total electrons. Now, The next thing you need to do is, we're going to just add this. This is actually kind of in between 5 and 6, would be part of step 6. You're going to recheck the octets for everything. So I need to make sure that all the octet rules are followed for all of the elements, except for hydrogen. Hydrogen only needs 2. If necessary, make double or triple bonds to fulfill the octet rule. So looking at my diagram, oxygen has 8. Oxygen has 8. Each line counts as 2, so 2, 4, 6, 8, 2, 4, 6, 8. But around sulfur, I only have 2, 4, 6. So I can't leave the diagram this way. I have to do something in order to complete the octet of my central atom. When your central atom does not have enough electrons, you can take, and it doesn't matter which oxygen you use, you can take a pair of electrons from one of those oxygens and you can move it up to the middle and make a double bond. These disappear, but still now sulfur has 2, 4, 6, 8, and this oxygen has 2, 4, 6, 8. So all of my octets are complete and my total number of electrons is still 18. So that's my last step. Okay, that one I wanted to take our time through a little bit. And on the next couple, I'll go through them fairly quickly, but there's just a couple of things that are different here, which is why I added different examples for us. So let's go ahead and add valence electrons. So nitrogen has 5 and oxygen has 6 times 3. So that's 1823. And then the fact that there's a negative charge right here means that there's an extra electron. So I have to add one more to get my total number of electrons for that particular diagram. And now from here, everything is going to be the same. I'm going to start with my nitrogen in the middle. I'm going to connect everything with a single bond. And I'm going to, so that's step 1 and 2. I'm going to complete the octets around my outside elements. And I'm going to recount my electrons. I have 2, 4, 6 in the middle, 8, 10, 12, 14, 16, 18, 20, 22, 24. That's the correct number of electrons. So I don't have to add any electrons to my central atom. But nitrogen still does not have a complete octet. It has 2, 4, 6 only. So I have to take a pair of electrons from any oxygen. It doesn't matter which one you choose. I'll take it from this oxygen right here, put it in the middle, and create one double bond. That's going to give me 8 electrons around nitrogen and also 8 for that top oxygen there. Anytime you have an ion, so this is nitrate, it has a -1 charge. Lewis dot diagrams, Lewis structures for ions have to have brackets around them with the charge on the outside. Okay, let's take a look at carbon dioxide. Carbon has 4 valence electrons. Oxygen has 6. There are 2 of them. So that's 12 plus 4. That's going to give me 16 electrons that I need in my diagram. That was step number 1. Step number 2 is to connect everything with single bonds. So here's my carbon, 2 oxygens on the outside. And step number 3 is to complete octets around the outside. Now let me recount my electrons. I have 2, 4, 6, 8, 10, 12, 14, 16 electrons, which is the correct number of electrons. However, carbon only has 2, 4 electrons around it. So it needs 4 more electrons, which means that I'm going to have to create double bonds. Molecules want to be as symmetrical as possible if they can. So what I mean by that is if I'm going to take these 2 electrons away and put them here and create a double bond, instead of creating a triple bond here, what would be more stable as a molecule would be 2 double bonds. So total, I still have 2, 4, 6, 8, 10, 12, 14, 16 electrons, and everything has a complete octet. All right, we're going to do these practice ones in class. So you don't need to worry about doing those right now. The only homework is for you guys to watch these video notes. So hang on to these, bring them back with you to class next time, and we'll go over those together, practice those, make sure we're good with drawing Lewis structures. Okay. That was a review of drawing Lewis structures the way you guys did last year. Now in AP Chemistry, you have to know a couple of exceptions. You have to know about compounds that don't have to have octets, so they can be incomplete. meaning they don't have to have 8 electrons around it. Also, you have to be able to draw diagrams for elements that can have what are called expanded octets, or they can have more than 8 around it if it's the central atom. Okay, so there's only 2 incomplete octet exceptions. Those are going to be for our elements beryllium and boron. So boron can have just 3 bonds attached to it with 6 electrons, and it's totally fine like that. It's complete. You don't have to worry about making double bonds or anything like that. Boron oh, sorry, we already did boron. Beryllium, super uncommon actually for beryllium, but sometimes can form just 2 bonds. It doesn't have to be double, it doesn't have to have a complete octet and just have 4 electrons around it. All right, these expanded octet problems, these are the ones that show up all the time, and we're going to spend a lot of time with expanded octets because it gives you such a wide range of shapes of molecules, and so we're going to have to learn all of those shapes and why they form those shapes and how they form. So here's the deal. If the element is in the 3rd row or below, if it's a central atom only, okay, not the outside atoms, but central atoms, if they're in the 3rd row or below, they can have more than 8 electrons around it because they have a d sublevel that's not completely filled. So there is room for electrons to go there and for extra bonds to form. So here's what that looks like. These are actually really easy to draw because you can just put extra electrons on the central atom and it's okay. So SF6. You are still going to start with the same steps, which is to add valence electrons together. So sulfur has 6, fluorine has 7, and there are 6 fluorines there. That's 48 electrons. These expanded octet molecules have a lot of electrons. Okay, so our central atom is sulfur. Now, because I know sulfur is in row 3 and it can have an expanded octet, that means that all 6 fluorines can go around the outside of sulfur and it's fine. That gives me 2, 4, 6, 8, 10, 12 electrons around sulfur, and that's okay because it has an empty d sublevel. It has room for those bonds to form. Okay, so you're going to connect everything with single bonds. You're going to complete octets around the outside atoms, and you're going to recount electrons. In this particular diagram, that is 48 electrons. And so that is my Lewis structure for SF6, sulfur hexafluoride. By the way, sulfur hexafluoride, you know how helium makes your voice go high? Sulfur hexafluoride makes your voice go really low. Just fun fact about sulfur hexafluoride. All right, let's do ICl4. So iodine has 7 valence electrons. So does chlorine. But there are 4 of those. Negative sign here, this is an ion, so that means there is an extra electron. I'm going to add all of those together. Gives me 36 electrons that I need to have in this diagram. My iodine is going to go in the middle, and I'm going to go ahead and draw my chlorines. By the way, I'm going to draw them like this, but if you draw them so they look like a plus sign instead of like an X, that's not wrong. That's okay. So I have, let's see, connected everything with a single bond. Now I'm going to go ahead and complete the octets around the outside atoms. And I'm going to recount my electrons. So I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, but I need 36. If I don't have enough electrons on my diagram, what do? We put them on the central atom. So I have 32 here, I need 36. So here's 34, here's 36, and that is okay. My iodine has 12 electrons around it, but it's okay, it's got room for that. Any element in the 3rd row or below, if it's the central atom, can have extra electrons around it. That's going to determine all the shapes we're going to talk about in the next couple class periods. How many bonds are attached to it versus how many unbonded pairs of electrons are going to determine the shapes of the molecules, which will determine the different properties that they have. So That's really it, you guys. When we come back to class, there's some practice here for expanded octets. We're going to do these in class also. So you don't have to worry about doing those. If you want to get a head start and just kind of think through this, you are welcome to do that, but you are going to be given time in class to do that as well. So that's Lewis structures. We're going to do a lot of drawing Lewis structures in class next time. So have a good day, you guys, and I will see you in class.